Hi guys, we'll be doing 6.9 integrating using substitution. So right here, we're going to start with number 2 right here. And what we do is to use u substitution. And for our u is the inside of just anything. It could be inside of square root, parentheses, brackets, whatever. Just a variable inside whatever I just said. So for the u, I'm going to put this one. I'm going to use this one because I'm thinking ahead of time because I want my square root of x to cancel out, and you'll see. So my u is my square root of x. My du, which is the derivative of u, is 1 over 2 square root of x. Now, as you go along with calculus, you will learn that this derivative real quick. I haven't memorized. But 1 over 2 times square root of x times dx. Now I want to get dx alone. I will multiply 2 square root of x to both sides, and that will be 2 square root of x du equals dx. So now that I got my dx, I can already see, based off what I gotten already, that my my square root of x will cancel because that's my dx and it's on top. You see, square root of x, square root of x. So that would just be square root of cosine u to du, and I'll put the 2 in front. I don't know, that's just how we were taught. So for this, since now we just gotta find the capitalized f of x, which is the antiderivative, so that would just be 2, the derivative for cosine is sine in integrals. So, and I realize it doesn't have a negative, and I gotta get that in my head because I almost said negative, but it would just be sine u, bring it down, plus c. And so what we do here is, since our u, we plug in back our u. So it would just be 2 sine square root of x plus c. And that is our answer. Next up, we would just be doing definite integrals using u substitution. So let's get started. So you can see that inside parentheses, that will be my u, because it's functions that are inside of parentheses, brackets, what I just explicitly said in the problem before. But my u is 2x, and my du, which is the derivative of u, is 2 dx, and divided by both sides to get dx alone, and dx equals du over 2. So now automatically I can plug in my u into my equation. I can plug u in for the x, so it'll just be u dx. Now, for this integral, I'm gonna find the antiderivative, which is, oh, my bad, I meant to put du over 2. I'm going to find the antiderivative, which is 1/2 negative cosine u evaluated I pi over 2 over 0. Now for this one, we're just going to plug in our u. So I'm just, not our u, yeah, our u, which is 2x. So I'm just going to go ahead and do that because I don't want to forget it. So it'll just be negative 1/2 negative cosine. Oh, and the negative cosine is like the derivative sign in integrals. So yeah. Over 2, 0. And I'm gonna come back and I'm gonna set it up. So I forgot that when you're setting it up for the definite integrals, it will be b minus a. So this is your b, which is this one, and this is your a, which is that one. So that will equal to 0. And this one over here, negative 1. Oop. It's supposed to be negative in front of there. Minus negative 1. Oh, sorry. That's not going to be a 0. My bad. That's going to be a negative 1 because it goes over here. Whoops, because cosine on the unit circle, cosine of 0 on a unit circle is negative 1. And that will equal plus 1 plus 1, 1/2. And it'll just be 1, 2, equal 1. And that is your answer.